Hello student, let's try to understand first law of thermodynamics. We are going to study the derivation student. So that is the case 1 we are studying student. In this chapter we have to study PV work student. Pressure volume work student that we have to study. What is the concept here student? That is a gas is filled into the closed container having the piston on it, movable piston, right? This is the piston student. Now piston is what it is doing student, it is applying the P external, right? Here gas are filled student. Gas is what they are doing, gas is also applying the force on it student. Okay, so if suppose student P external greater than force, P external greater than force student, so that is going to be compression. This is the compression. And if P external less than force, this is going to be expansion student, expansion. Let us see after some time student, the gas expand, it is up to here. So how much volume change student? This is the distance change is the dl, very small student, this is dl, and this is the L, total is the L, right? And this is what is student, this is the area of cross section. So work is equal to what student? Work is equal to force into displacement. This is what? Displacement. So in other word, if you are in the pressure volume work student, if you are talking about, so what is the force here? What is the force? So you know student, pressure is equal to force per unit area. So F is equal to P into A. So what we can write student, P, this what the P into what we will write student, A into displacement student. Displacement, how we can write student in the term, if you talk about, if these all things are very small, displacement is there, so dA, right? It will be dA, and the displacement will be what we can write student, the displacement we can write dl. So what is the student? Area into length, area into length, area into length is equal to what is going to be volume. This is, so here is the P external, this will be what student? External, because internal nothing is there, internal into dV, this is the work. Now we have to understand student, it can be, that is if it is the expansion, so expansion W is equal to minus P external, and if the work done is a lot student, so delta V. If compression student, if compression, so W is equal to minus P external delta V, but here is compression, this will be what student? Positive sign, right? So this is what the derivation of the work student. Or also you can write student, W is equal to minus P external V2 minus V1. Here you can write student, W is equal to P external V2 minus V1. So this is what the answer student, derivation of the, in case of, if you are talking about the here is the expansion, this one is the expansion nice student, so V2 will be greater than V1 in case of the expansion student, V2 will be greater than, and in compression V2 will be less than V1. Expansion is there student, so force will be greater than P external. Force will be greater than, and in case of the other, force will be less than P external. So this is all about the answer.